Hello everyone. This is a little experiment I'm trying out, streaming game development with Unity3D, and specifically this time I'm going to be giving an overview of RobotArms, which is a library that was developed where I work at Boldly Games. We use it there extensively, and I had gotten some questions on its usage, so I wanted to go over kind of just an overview of how to use it in the context of a simple little game that I'm going to set up sort of the basic start to. And then if that goes well, maybe I can do some streams of continuing to develop that. So to start off with, I've got here just a empty project, and I'm going to go ahead and create that. Let Unity do its thing. And I should probably put the chat just in case anyone joins. Put that somewhere where I can see it. All right, so Unity is set up, and now we can go ahead and get the project set up. So first thing we need to do if we're using RobotArms, I'm just going to go ahead. If we're using RobotArms, we need to actually import RobotArms. So RobotArms, it can be found at its page here on Bitbucket. So bitbucket.org/dkunz/robotarms. You can go ahead and download that using Git, or you can just download the repository if you want to, under the downloads link. Now, once you have that, I already have that downloaded. You go ahead and open that project. There's a solution that you can open. And I've got that solution open right here. There's two projects inside it, RobotArms and the editor. And we do that because Unity requires that if you're going to use any editor API, you have that inside a different directory. So we can't have just one big DLL that has all the files. We have to have one for the regular RobotArms and one for the editor stuff. Okay, so let's go ahead and compile these. So you just right click and build, or Command K. That will build it. Switch back to the directory where it is. And under RobotArms, we have RobotArms and RobotArms Editor. These are the two projects. So if we go under bin, debug, we'll find RobotArms. This is the main RobotArms DLL, and the MDB is just for debugging. So if you have an exception and you want to be able to see a stack trace and see exactly the line where it happened, like if you want to be able to go in the source and see what's happening, that's what this MDB file here is. So I'm going to take that, and I'm going to go over to where we just created our Unity project. Actually, the better way to do this is to come in here and right click and say Reveal in Finder, and that'll just open up your asset directory for you. So I'm going to create a directory inside here. I like to have something called code and something called content, and I just do that this way with the underscore, because when you import things from the asset store, generally speaking, it's a bad idea to go and move those around and put those in different directories, because then when you want to do an update, the update's going to go back into that same directory, into the original directory, and you're going to have to remember where you put it, and it's a huge mess. So I just leave everything that comes in from the asset store alone in its directory. And I'm going to change this track because this is obnoxious. Hold on just a second here. All right. So sorry about that. I need to figure out how to get the Twitch chat without actually being on my own Twitch channel. Give me just a moment here. That's why this is a test run. Pretty sure I just need to mute my own stream, and that was my problem. So, all right, so we do that. Get all these things worked out here for next time. All right, so what we're gonna do now is we've got RobotArms downloaded. We want to import it, so we're going to copy the RobotArms DLL into our code directory here. I generally make a lib for things I'm pulling in that aren't my actual like direct code. And then we'll need to come back up here in code, and we'll need to make a new folder called editor. Editor is the special folder name that Unity wants so as not to blow up when you put editor files in. So same kind of thing, same structure. Under RobotArms editor, you have a bin debug, so we're building in debug mode. We could of course build in release mode, and it would be release. And we're going to copy over the editor versions. So we'll copy those over. And that should be it in terms of getting RobotArms up and running. So if we come over here, let Unity do its import. There we go. We've got our files. Nothing too spectacular yet. So this little test project that I'm wanting to do, it's sort of inspired by this game, Sproggywood, in terms of just their movement and their abilities. So this is a fairly traditional turn-based roguelike, and every time you move, it advances one turn automatically, or if you use an ability, generally that also advances a turn. There's a couple abilities where that's not true, but in my version, every ability, basically movement is just another ability, and it will advance time one tick. So what I'm going to do is I'm going to start going through the process of building out this structure, except I'm not going to be the fake perspective. I'm just going to go straight top down for now. And to do that, I'm going to use some assets that I got off gameicons.net. So I have a directory here with some images. You can see here some icons, just some real simple icons. We can tint these. We have one for our character and then some enemies to run into. And of course, we could do things like find some trees or terrain type tiles for now. We don't need to get too complicated with that. Probably we'll just have blocking terrain and open terrain for now. And we can either do the collision system first or like the combat system first. So we'll just do it real simple. If you move into them, you deal damage, and then after you've moved, every enemy that's able to deal damage to you then hits you once. So in this example, if I was this character and I press left, also in Sproggywood, this is something that eventually would be nice to get to, is this bar indicates how much damage you'll do. So if the bar was halfway, it would indicate that the first hit's going to take that much health, and then the second hit would kill them. If the bar was something like here, it might indicate that you need 5 hits to kill them. But in this example, if you were to hit this mushroom would die, and then because both of these mushrooms can hit you, they would both attack you. That's kind of how that system works. So every turn, you choose what you want to do, you act, and then all the enemies act. That's kind of the system. All right, so this is meant to be kind of a general RobotArms overview. That's why we went through getting RobotArms. I'm going to go ahead and pull in the content, these sprites here. I'm going to go ahead and pull those into Unity. So we're done with this. We'll pull these in. Okay, there they are. I have it set to 2D, so these are all sprites. We can go to our main camera. Everything's fine here. We're at 5, orthographic, all that's fine. This is just the basic Unity 2D system. So the first thing when you're using RobotArms that you need to do is you need to add one thing to your scene, which is the RobotArms coordinator. So you go ahead and just toss that in, and it should look something like this. There's a script, there's no blackboard, we'll get to what that is in a minute, and the enabled processors. And these processors, you're just kind of like, hey, where did these come from? We just started. These are just built in. And if nothing is using them, they won't do anything, so you can just basically ignore them. But that's really useful for if you think maybe you wrote something wrong, you want to know if your processor is running, that's where you can look for that. So let's go ahead and let's start off and let's create something. So probably the simplest thing, generally speaking, if you were to do normal, like traditional Unity development. In fact, let's do that. Let's write this the way you'd write a normal Unity class. So you do something like this. You would go and you'd grab the player and plop it in the scene and put it somewhere. And this scale is not going to be correct, so let's go ahead and let's move out a little. We could scale everything down, but I think this is easier for now. Just leave everything at the scale that it's at, and move out a bit. Move out a little bit. Actually, let's see. If we move this 1 unit, oops. It's gonna be our sprite. We actually probably do want to scale this down. That way we can move things by 1 unit, and everything will move very nicely. So probably we want this to be not 0.1, how about 0.2? Yep, looks like 0.2. So for everything, if our sprites are 0.2, then they are the size of a cube, and if we move them 1 tile space, they'll move over 1. So that way we can just increase by 1, and they move nicely. Oops, not 10. Okay, so we need our sprites to be 0.2, and we'll put our camera back where it was. You'll find that I test a lot of things and then go back and forth, so if it seems like I don't know what I'm doing or I'm going back and forth, that's just kind of how I work. Try things out. Oh, that wasn't right. Let's go back and do it a different way. So I create our player script, and we toss it on the player. So we have a player, and clearly our player should be able to do something, and so it would seem like the most natural thing to do would do something like if input get oh, I'm in the wrong project here. It opened the file, but Unity doesn't actually force a project load, so we'll just go do that. All right, so here's our player, actually in our project. All right, if input, and we can get axis, get the horizontal axis, and we can say if that's, well, there's a whole bunch of ways we can do this, of course. Let's do it the really simple way. If it's greater than 0, it means move to the right. So if that's the case, we are going to move to the right, and we would do something like transform.translate, and we want to move 1 along the x-axis. If we look, that's the local, so we want to move one along the x-axis. So we translate by vector3.right times, or just vector3.right, and that needs to be in world space. I guess in this case it doesn't matter, but if we ever rotated it, we would want to make sure that's in world space. So we translate by 1 if it's, this is get access. We actually want get, let's just do get key down for now because we don't want to continuously move. So we'll just do D to move right. And then of course we'd want to be able to do the same thing for A, and we'd move negative right. Okay, so let's test that much. All right, so I press D, we move to the right, I press A, we move to the left. So we can move back and forth on a grid. And of course, from here we would expand that out, and we would start doing things, up and down, and then starting to check, that tile, does it contain an enemy? If so, do an attack. And we would start to put a lot of code here in the player. Like eventually the player would end up with, probably we could have like health. We could have a couple like bools for things like, stunned or snared, or if we have different statuses like that. We could certainly have an int for attack. We might even have move speed. I don't know that there's any characters you'd want to move 2 spaces at a time, but theoretically you might want to have a character move 2 spaces every time they move, or up to 2 spaces. So we could put something like that. And then of course you'd have things like you'd check for the activation of abilities and that sort of thing. So that's kind of like the normal Unity way to do things. We would put more and more stuff in here. Check for combat, check for ability use, and so on. Okay, that is very different from how the RobotArms approach is going to be. So RobotArms, the idea with RobotArms is to keep your data and your logic separate. You want there to be two distinct places where each one of those go. Where normal object-oriented, all of your data, and this is public data, which is maybe uncommon for some people who make everything private. So you might, right at the beginning, make all these things private and then use like a serialized field to show in the editor, or show in inspector, to show it in the inspector, or maybe you don't. Maybe you just get by without ever seeing things in the inspector. In RobotArms, what we want to do instead is we want to define the data that our player needs. So our player needs a couple things. It needs a kind of like a pending move. Oh, the other problem here is that this whole system instantly moves you, and probably what needs to happen is probably your move needs to be submitted somewhere so that it can be executed, and then the enemies can all execute their turns. So in a sense, well, depending on the rules of your game, it might be that if you move to a new space, like if you start not touching this enemy, like say this is an enemy, and you start in a space not touching the enemy, if you move, if the enemy chooses their move at the beginning and it's just kind of pending and it goes off, then when you move here, you wouldn't get hit because this enemy didn't try to attack you at the beginning of the turn. But if the enemies go after the players, meaning the player moves and then the enemies choose their action, like in two discrete phases, then the enemies would hit you. So either way, the ultimate goal for this is to make it work single player and then make it work multiplayer. So eventually I'm going to need a system by which I can have all the players submit their turns, and once all those turns are received, process them all, and then tick the AI and let all the AI actions go. So it makes sense that somewhere there'd be like a action manager, turn manager kind of thing, and then when you decide what to do, you decide to move or use an action or whatever, that would get submitted. You might have a singleton instance. It might be a reference that's drug onto the player. There's a lot of ways that you could get to that. And you call some method on that manager object, and you'd submit your move. And your move might be a class or a struct, or maybe it's just a enum value if it's a very simple system and there's only a couple different moves that you can possibly do. In RobotArms, it's a little different. So the idea is we want to be able to do each part of the overall task of what's going on separately and independently of each other. And then we'll have something that kind of looks at all those parts and works them together to achieve something. And if you look at the RobotArms example project on here, this is a little different because I'm just kind of coming up with this as I go. I haven't actually written this yet, so I don't know where it's going. But if you go to the example project that's part of RobotArms, it's under Docs Unity Asteroids example. If you go and you look in here, you'll find a whole Unity project that's an implementation of asteroids, or a small variation of asteroids. So that's a full project with everything thought out and complete. This one is a little more off the cuff. So what I'm going to do here is I'm going to add some new components, and I'm actually going to create a folder for this. Why is there no? Oh, it's add folder. There it is. I make a components folder. Components are what we call the part that holds the data. So for this, I'm going to have a player input, and then I'm also going to have another one for player stats. Those are going to be basically two parts of what goes on with a player. And for this first one, I'm going to, for player input, all we want to know is, let's see, so everything on a component's public, and this is player input, and we want to know what the player did. We want to record what the player did. So we could do an enum for which, like if it's moving in a direction, we could have probably one big enum for, let's see here, it could be like input type, and it could be something like, I guess up, down. There's only going to be a few inputs for this game. up, down, left, right, and ability, like ability 1 through 4 kind of thing. What else could we do? We could open the menu, we could do things like that. But for now, let's just capture these things. So you can only have done one of these things. That's why it's in enum. If they were not mutually exclusive, you could do flags on your enum, but I would probably just do a series of bools. And the idea here is, all we're trying to do is we're trying to figure out what your input is. And we want to record that just independently. So every component, generally speaking, has a processor that goes along with it. And the processor is usually named the same kind of thing. So if we have a player input component, we have a player input processor. Okay, so there's our player input processor, and I'll get rid of this template stuff that I have from work, so just ignore that stuff for now. Okay, so, oh goodness, this processor is a little out of date. I need to change this a little bit. We recently updated RobotArms, and I haven't updated my snippets. So we override process. Override process. There we go. We override process, and what this is going to do is process is where you say, this is where all your logic goes. So in the component, you have some data, in this case, one little tiny piece of data, just the player input. And in the player input processor is where we do everything that affects it. We change it, read from it, write to it, etc. So what you do is you inherit from a RobotArms processor, and you declare all the different types of components that you expect that game object to have. And any game object that matches this, like any game object that has a player input on it, will automatically be passed into this process method one at a time. So you're handed the game object and its associated player input component, those two things. So in here, what we could do is, this is basically where we would do the check from before. We could say if input get key down, key code A, for example. If that's true, and I'm being a little inconsistent in my brace placement here, I need to update that to also do that. Okay, so we've got our player input has just input, and our player input processor can potentially write to that input. So if we pressed A, then the inputs field equals left. And we could do a switch. Well, we can do a switch on that. What does get key down? Returns, yeah, just bools. So we just have to do a series of else-ifs, unfortunately. We can get much nicer input than this if we use a input manager like Rewired or something like that. But for now, this will do. So we're just going to do this. If we press D, we want to go right. If we press W, we go up. If we press S, we go down. And this probably seems really overkill to you at the moment. Like, why the heck would you do all this work when you could have just basically done this? I mean, I guess there's a couple more lines, but if we put the W and the S in here, then, and in fact, this is doing more work because this is actually, this is up, yeah. And let's see, I think positive, yeah, positive Y is up. Okay, good. So W is up and S is negative up. So that's down. So in fact, this is doing more because it's doing both the check for the key as well as the actual application of that. So let's get to the actual movement. We've got a player stats, and this is a component. Strip off this stuff. Okay, So we've got our player stats, and our player stats has things like health, move speed, things like that. And this is where if we had player and we had move speed here and we multiplied this by our move speed, just to make this all apples to apples. Okay, so we've got our player stats, which has, say, move speed. And what we want to then do is have another processor. And this processor is concerned with, so this processor is concerned with the player's input and affecting the player now. So this is a processor that wants to take the input that we recorded. So one processor writes to the input, and another processor that is completely unrelated. This is kind of like where it starts to pay off. Even this is an incredibly trivial example, but one processor writes to player input, another processor that has no knowledge of that reads from player input and does something. And this is what allows you in a big project, and so we've been using this on my game Emberscape, which is a pretty big project for 2 programmers. And we're able to add new features pretty frequently that we never envisioned before and that don't have any conflicts or interference with our existing code. Because everything, all the processors know how to do is read and write from these components, these like pure data components. And as a result, you can't ever like change a method that was only being, that you thought was only being used by one other like consumer. Or you have this tendency maybe to write methods that you think are general, but over time they really only have one consumer, and that's really the only reason you expose this data. And so they kind of morph into this like very special like helper method for this other class. And as a result, those 2 classes, like the tendrils come out and they start to like interleave with each other. And then when you go to say, oh, these things, I actually need a new thing to participate in this. I need a third thing in here. I need something in between them. You go to pull on that, and it's like, oh, wow, I didn't realize those were as intertwined as they are. I think that's a fairly common occurrence once you've done any sort of like large-scale OO, and especially Unity, which encourages that kind of thing for a while. So RobotArms is an attempt to say, no, every processor only knows how to talk to a little bit of data, and we can read and write from that data independently of that processor, and we can then add new things, new pieces of data, new processors without interfering any of the existing parts. It's not to say you'll never have to refactor, but it makes things much easier when you do need to. So let's create a player movement, for example. So a player movement processor. All right, again, I apologize, my templates are messed up. In fact, let's just go fix that right now. Let's go in here and go to our snippets. Code templates. So you can create your own code templates if you want to in Xamarin or MonoDevelop. You just come in here into your preferences, go down to code templates. I have one for DL for debug log, since that's a pretty common one, and then SF for string.format, and then I have component and processor are the 2 that you'll see me using a bunch here. So component, that one doesn't change any. I have to strip off the namespace because we're not doing my work project. We're doing this. But the thing that just changed recently from RobotArms was this. So type goes here. So anything you put in $signs becomes a point where when you hit tab, the cursor will move to it. And if you put the same type in multiple places, like type is there and type is also here, it will fill in both of those. And in fact, type is also down here. So what we're going to do here is we're going to put type, and this will be component. All right, and then end is a special token that basically says when you hit enter and you're done, it moves the cursor there. So this is the one argument version, the I depend on only one thing version of a processor. Oops. Oh, that's a component. Processor. Right. So this is going to be a processor that depends on player input. So it becomes a player input processor. That's like pretty standard. Let me kill those. Let me kill namespace. If someone has a way to have templates in MonoDevelop or Xamarin where you can like change that namespace easily, let me know. I've never found a good way, so I just set it to the one I use most often and delete it when I don't need it. So this is a processor just like the player input processor, that only relies on player input. At least, this one's going to need to rely on more than just player input. It needs player input and player stats because we need to know the move speed. So we have a piece of data over here, your input, what did you do? And we have another piece of data over here, your stats, for example, what should happen when you activate any of your abilities, or how far do you move, or things like that. So we have two, which means we're handed both the player input and the player stats. Okay, we're handed both of those by RobotArms. So now what we can do is we can do something like, let's just apply movement, for example. So here we do have an enum, so we can switch on the, sorry, that shouldn't be component, that should be something like input. So we'll switch on the inputs, the input field of that, and sorry, my curly braces are not stacked correctly. Okay, and if we come up here, we can create all the switch labels, boom. So if the input that was previously entered by the player input processor was up, then we want to move up. And we've already written that code. That's this code right here from our previous example. So we'll just plop that in here. So the thing that we're translating, this is the game object that had the input component that was up. So this is the game object that we want to translate. So we just change it like that. The entities transform, translate, up, and how far do we want to do it? Well, that's based on the stats move speed. The move speed lives on stats. That's why we needed to say that we want both player input and player stats handed to us. So that's up. Down is similarly, down is negative, up is positive, and then we can do left and right, which are left is negative right, and right is positive right. Okay, and for now, ability 1 through 4 are not implemented, so we just leave those alone. So what we should be able to do now is plop a player input and a player stats on a character, and see that it can do the same thing. So this is our sort of regular player, and this will be our sort of our RobotArms player. Oops. So this is kind of our reference, just the sort of the existing Unity style reference player. And so we're going to remove these components, and we're going to put on here a player input, player. I apparently forgot to either save something. Oh, this is a player movement processor. That's what we want here. And I somehow managed to completely screw up my naming. Processor. Okay, player movement processor. Try that again. And I left that in from before I'd fixed my template. So that goes away. And now it compiles cleanly. Okay, so the two things we want to add are player input and, oh, I just realized something, player stats. So player stats, we'll just say a move speed of 1 for now. Now this is a problem. We can't use this as the input because you would always have an input. We clearly need to have a none. Which is pretty normal when you have an enum. You have a none as the first element. So now we can default to none. There we go. Okay, so by default, nothing will happen. Let me move these so they're not right on top of each other. Okay, and seems I was getting an exception. Oh, right, because we never implemented none here, because we just added it. So if none happens, don't do anything. By the way, if you have any questions, I see people kind of bouncing in and out. If you want to know anything, ask any questions, please ask. Someone should, can you see this? I assume people can actually chat and I can see it in here, that I'm in the right place to do that. Okay, so if I press right, well, that was fun. It just took off and kept going. And if we look at the player, it's fairly clear why. We pressed the button and let go, and the input stayed right. It got set to right, and so it started moving. That all worked correctly, but it didn't stop moving. Also, our other player didn't move because we recently added this concept of move speed. So if we do this, and now I press right, top one takes off, whereas the bottom one only moves one. Press left, it'll eventually come back. If we press left, yeah, there it goes. So clearly our input processor is not doing its job quite right. It needs an else. Now that we have a none, the none that we just added. If it was none of these, it needs to set the input to none. Okay. So now we press right, they both move right. So these are now equivalent things to each other. And again, you may be saying like, man, that seems like a lot of work for something that's equivalent to, you know, here's the traditional Unity style of just checking for 4 keys and translating by a certain amount. And here's the player input processor setting the key that we want. And here's the player movement processor, you know, doing something with that. Obviously, only this part is strictly necessary for what we're doing. The benefit comes, and hopefully this will be more apparent as we go, and you can go look at the asteroids example, like I said, in the test project. But the value of this comes as you scale up. Because now, let's say that, you know, for whatever reason, you don't want to, you want the player to move, but you don't necessarily want to check a key. So something that comes up pretty often is you start with your keyboard input or keyboard and mouse or whatever, and then you want to support something new, a gamepad or touch controls or something like that. Well, you're explicitly checking for a key in your code. You're explicitly checking right here. If the key is down, translate. There's no way to get to this translate without going through this guard right here. And of course, you could expand that out and say if the key code D is down, or you know, a certain gamepad access is greater than a certain value, or if there's some sort of swipe event, all those things could trigger this same translate. Or more realistically, you'd have an input system that would, you'd have like a current input type of keyboard, controller, gamepad kind of thing, or touch, and you would sort of know which one you're on, and you would pull the right one and check to see if it works. But the point is that all of that is wrapped up, all this like figure out my input and all that junk is wrapped up with like, all I want to do is move right. Like these things, there's this word, when two things that are like, well, that can be unrelated or are unrelated are unnecessarily combined, it's called complecting. And these things, I would say, are highly complected. And you would think in your mind, like, we only move right if you press the key. Like, those things seem incredibly related to me. But in reality, they don't have to be. And some examples I could give you would be, what if the input for this character was received over the network? And what if the input for this character was being driven by AI? So you have like a drop-in, drop-out multiplayer kind of feature. And you want to be able to take over, and then like, okay, I'm out, and you drop out. Well, we want an AI to now drive what happens with this character. And in the example here, so this is running, there's no way for me to get that bottom one to move unless I press a key on the keyboard. But now, because we've separated these two things out, if I set this to right, this isn't going to be quite right. Oh, this is funny. Get to not quite contradict myself, but these processors are running in the wrong order. So player input is running, and it keeps setting my input back to none, unfortunately. That's pretty funny. The processor keeps setting the input back to none. I would need to put these in a separate order. So you can explicitly give an order to your things, and I could do something like make player input run later. Whoops. Processor options, and I could give this, you can see that we can give this priority, and if we make this run, it works the same way Unity's priority system does, so negative numbers are earlier than positive numbers. So negative infinity runs first and positive infinity runs last. So if we set this to run later, the player input, then whatever was set on it should be read first by the player movement processor and interpreted into some sort of input, and then set back to none. So let's just try that. Run this again. Well, that's unfortunate. So Unity's, what's happening here? Unity's processing my editor input after both of them have run. And so probably before, no, after? That's weird. Unity, like the player input processor is running and resetting this to none. So there's two ways, if we want to solve this like long term, two ways we could solve this. One would be to make the player, like one of these processors, responsible for clearing it. That's really unfortunate. That's a bad interaction with the Unity editor. Yeah. So if we took this out, I could show you. I'm going to set the player move speed very low so we don't go flying off into infinity here, like super fast. Oh, this is an int. Awesome. Well, let's zoom out and you can see. So if we start this and we turn off the none resetting, I can just set this to right and it goes off, and I can then set it to left and it just comes right back. And so I could drive that with an AI, I could drive that over network, I could drive that a whole variety of things. If I needed that to really work through the editor here, I would need to think about how I can inject that value and not have it get cleared. Probably what I would do is I would have the player input processor, I would have something that would allow me to turn the player input processor off, like a flag that it could look at, and the player input processor just wouldn't run if a different processor was running. Yep, that would be my solution. So there's something we haven't talked about, which is the blackboard. It's here on this core RobotArms component here. There's this blackboard, and you can put any game object you want here. You just assign it in. Just a regular model behavior, has whatever you want on it, and that object is accessible by all your processors. So that's a really good place to put common things that multiple processors need to see. And if they need to communicate not through a component, they can do it that way. So they could communicate through the component. Like our player input might have a public bool is locally controlled, and this bool, right? If it's locally controlled, meaning like if this processor is supposed to be running this value, then go ahead and run through and set these values. Otherwise, don't do anything. And then it would be pretty simple here to come back into our player and say, okay, it's locally controlled, so we'll go ahead and we'll do that. And we can zoom back in, and I can press right, left. Okay, if I say it's not locally controlled, now RobotArms is not processing it anymore. The RobotArms input processor is not. And if I click this to right, or left, or down, or whatever, it will just go ahead and the movement processor, which knows nothing about this processor, which knows nothing about the player input processor, will just do whatever it does, right? It'll just go through and apply these values. So that would be like another way that they could communicate, the two processors, is through the player input itself. So that's just an example. There's also some other things we could do. We could check the player input at a different phase, like during late update or something like that. That's not great. Well, late update runs at the same rate as update, so you won't have any issues with like if you run it fixed update, you can lose key presses and whatnot because you're not running fast enough, and they can press and release within the window of between fixed update frames. That wouldn't be a problem for late update. But anyway, so that's kind of a side issue there. So let's keep moving here. So we've got our player input component that has input and if it's locally controlled, and we have our stats, which has things like health and move speed. And we've already used move speed. We can go try that out. We can say, what happens if you set move speed to 2? Well, Unity decided to recompile behind the scenes and breaks everything. So we'll try this at 2. And now when we move, it moves two per step, which is what you expect. So that all seems to be working. So the next thing we could look at would be, say, how would we store the world? How would we store knowledge of where everything is? And ultimately, this is probably going to be procedurally generated, but that's a huge pain in the butt to deal with right off the bat. So generally speaking, I'd like to start off by just plopping in some blocks and then building up probably an array of arrays or a two-dimensional array of enums storing the values of what's in each spot. So pretty simple. Let's actually just go ahead and create, let's create some cubes to represent the different kinds of tiles. I know it's 2D, but it's pretty simple to just use cube. And we'll use, let's see, we're in 2D mode here, but we want to go positive on the Z. So we go positive on the Z, that puts in the background, perfect. Wonder how important it is to know what kind of tile you're on. Like in here, you can see the tile that you're on, if that matters. Like if you'd ever get bonuses, well, that probably doesn't matter. It would just mean the grid size would need to change. Either, like we currently have the player at 1, probably the player would need to get smaller than 1, but still move by 1. That way the you'd be able to see some of the background through, or we make the character sprite transparent or something like that. So let's do this. Let's throw on let's make this sprites. Put some sprites in here. And then we can create another folder for materials. So we're gonna need a couple materials. Probably we'll have dirt and wall. Very simple. These do not need to be standard shader. They can be unlit color. So dirt is brown, and wall can be like a gray brick or something like that. And of course we could throw actual like textures on here at any time. Okay, so we've got our cube, and actually why use a cube when we could use, we actually now have a primitive. We've got our quad, which is properly aligned and everything. Gone are the good old days of having to import your own quad object just to get a something you put a sprite on that's not 100 polygons. All right, so there's our quad. This is dirt, and we'll make another one, and this will be our wall. It of course has the wall color. Okay. And that has some crazy big snapping. What is going on here? Weird. Okay. There we go. Now we got snapping. We would, I mean, in a real project, we'd use a tile editor to like nicely like paint all these things out super quick. We don't have that here. I don't want to go import that. So let's just do something real simple. We actually don't even care that we're like not on ground. There's no concept of falling through the ground or anything like that. So let's just do something real simple and put some dirt out. Actually, let's go 2D. Really hate the camera personally. Let's go turn that off. Okay. So, nope. There we go. Again, if you have any questions, please don't hesitate to ask. I'm just gonna do something, just a couple spaces to move around on. Something like that, and then we'll put more irregular shaped ones, a little path through there. So now we should at least be able to do something like, you know, can you move onto the space correctly? I'm going to disable this, you know, traditional Unity style one because we're not really going to maintain that. So this is our terrain, or maybe this is our world. And let's just plop everything under that. Actually, sorry. Make sure that's at 0, 0. Now plop all this under there. All right, so we've got our player. And we need to build up a sort of a data structure that stores all this stuff that we have here. So there's a couple ways we could do that. This will be our main scene. Okay, there's our main scene. Generally, I'd just make a scenes, but if we only have one, it's a little redundant. Since we have two, it becomes a little more important. Okay, so we've got our main scene. We want to grab all of these tiles and know where they're at, such that when the player input is moving, we can tell, did we hit something? Should we be allowed to move? And how many tiles should we be allowed to move? For example, if you are sitting, if you're here and you move up, probably you just move one tile instead of moving two tiles. Whereas if you're here and you press up, you should move two tiles, assuming your move speed is 2. So that would be the next thing to do here. And to do that, I would create probably a map, like a world map object, and it will have a component on it. It'll have like a world map, something like that. And this, of course, is a component. So we put it in components. And we go blow away all the default stuff. And it's a world map. All right, world map. And so the world map would have probably a two-dimensional array of values of what is in each tile. That's the absolutely most simplistic version we could do. Ultimately, there's probably an actual like little data structure for each element of the tile, each tile telling you history. If items are dropped, there has to be a place to like store that information. So eventually there would be like a little class that's like tile or something like that. But for now, we could start off with something simple and say like tile type. And this could have a few tile types, and for now it's dirt and wall. Those are our two tile types. There is no none for this because that doesn't make sense, that there's nothing in that tile. I guess there could be like, there could be like abyss or chasm or water or something like that. That's a discrete tile type. So there's two ways to do this. You can have a array of tile type arrays, so you get this kind of thing. Or you can have a multi-dimensional array of tile type, which guarantees that the width and the height will always be like consistent. Because if you have an array of arrays, you have this potential for like, let's say this is your first like array and it's, whatever, like 12 long. There's nothing that says your next array can't be that long, and you get this kind of situation, which clearly is not at all what you'd want for a map. You would want a completely, if there's 5 things in the first row, then there darn well better be 5 things in the next row. So that's what a multi-dimensional array enforces. So probably we'll do that, tiles. So we have a public multi-dimensional array, tile type, called tiles. And of course, if you want to do a 3-dimensional array or 4-dimensional array, you can go nuts. I don't know how many dimensions it goes up to. You could use a 3-dimensional array. I guess you could do 4-dimensional array. It depends on what you're building. I've only ever really used 2-dimensional arrays in practice. So world map. So world map is going to do things like, there's a world map component, so it sort of implies that there might be, it doesn't have to be, but there might be a world map processor. And in this case, the world map processor is going to be a little bit different than the other processors, because it kind of only needs to do its thing once. It doesn't it's not like continuously, like the other ones, their process methods are being called. They're constantly running and checking for input or moving or things like that. In this one, the world map kind of just has to build up that tile array once. And for that, we can have process, that's fine, but we actually use a different method called initialize. We'll probably end up getting rid of process, but we'll just leave it around here for now in case we want it. So initialize gets run once and only once. It's basically your awake or start from traditional Unity. And so you say initialize, and you're handed the same things, the game object and all the components that you asked for, in this case just the world map. So what we really want to do is we want to take that map's tiles and create a new array out of that. But if we're not sort of providing that data, like we're not providing an XY on the map component and then telling it to procedurally generate this, it's going to go into the scene and find it. So that's a little more complex. What I think we should probably do is, we'll come back to this in just a second. Ultimately what we want to do is assign something. So we need, we don't know what the width is, we don't know what the height is, and we certainly don't know what the contents are quite yet. But we do need to put in values for that. And then this is, you know, fill tiles with their correct types. Okay, before we do that, we need to find them. And the way we're gonna find them is we're just gonna do the simplest thing that could work. We're gonna find everything in the scene that has some property. And we need to know what kind of things these are. So we could do that via tag, or we could have a component. So you remember how I said that, actually, this is interesting. Right, I said that eventually you might want to have some data for each tile that can remember things. You know, it can know its occupant, it can know if items are dropped there, it can know if there's a thing that happens when you step on it, like an effect on it. It makes sense to do those sorts of things. So probably what we actually want to do is create a new component called tile and attach it to all these things, which that I've actually never tried doing that. Oh, it does work. Awesome. So these all now have that tile component on them. It's not a component yet. We have to go tell Unity it's a component. Oh, right. We need to first put it in the component directory. You don't have to put it in the component directory, but it's what it's our convention. And so we'll open up tile. If you don't know, Control-Shift-T or Command-Shift-T is your search by type. So you can just type tile, and it'll pop up here. So that tile type that we had before in the world map, this tile type really probably belongs over here inside the tile file. Okay, so there's our tile type, and a tile component. Really, if you want to change a model behavior to component, you just have it inherit from RobotArms component, and you have to import. My little template did all that. And then we get rid of all this junk that we don't need. And this has the type for now. I think that is the easiest way to go. And then, of course, you know, put other cool stuff here. So any other data that we want to stuff into a tile, we just plop it right there. So now back on our world map, we don't actually have a bunch of tile type array. We have a tile array. We actually just refer to those tile components. So on our world map processor, if we want to find all those tiles, sorry, one more thing we need to do. I was very, very bad before I did this. What I should have done is made both of these prefab, so it would be very easy to change them. Okay, so the dirt prefab is of type dirt, the wall prefab is of type wall. Now we can duplicate them. Something like this. Okay. And for the sake of consistency, let's make sure every tile is actually filled in a square grid, because that will make life a little bit easier on ourselves. That's a rule that's pretty fair to impose upon ourselves. So here we go. What we want to do is scan through all the tiles, figure out how many wide they are, and then put them, we basically want to sort them. And we want to sort them by ascending X and then ascending Y. So all the values that have the same y, we want to sort them, and then go to the next y and sort all those, and then we can figure out how many are at each y. That'll give us our width. We can figure out how many y's there are. That'll give us our height. We can then generate the multi-dimensional array and insert all of these into the list. Easy peasy. Okay, so what did I say here? We're going to find all the tiles. Sort all tiles by x, then y. Determine how many tiles are in a given y, and then determine the range. Or we could do the same thing. How many tiles are in a given x? It'd be the same way to get our y's. And then we can create a tile array, and then we can insert tiles into array. All right, all we gotta do is convert those comments into actual code, and we're good. We're done. We did the hard part. We figured out what we wanted to do. So we find all the tiles. There's something I'm gonna need here in a second once we get to sort. Well, let's find all the tiles first, and then we'll get to the next part. So all of these have the tile script on them. We can assume that we're doing things correctly, and we're not game object, not with tag, find. We can type, where's type? Find objects of type, there we go. We can assume that we're not putting multiple tiles on the same game object. That would definitely not be correct. So we can say this is our tiles, this is our temp tiles right here. And this will give us all of the tile components. From there, of course, we can get the game objects that they're attached to and move on. So this next one, sort all tiles by x and then y. This is where, if your inclination is to like bust out a big for loop and start like doing some sort of for loop inside a for loop kind of thingy, I'm going to stop you there. And the correct answer is to use link. So what we want to do is we want to take our tiles. Oh, I thought we were going to need another library. It's linked on the page down below under tools, good stuff. There's some extra methods that extend what link can do. I don't actually think we need it in this case. So we just need order by. And so the thing that we want to order by is we want to order by the x first and then the y. So if your y is bigger, then it doesn't matter where your x is, you're further down the line. So if your x, if there's an x of 100 versus an x of 1, but sorry, that's backwards. The x of 100 versus an x of 1, since the 1 has a y that's bigger, it is bigger than the 100. That's kind of like our ordering value. So the way this works is you're handed the tile component, and you have to give back a number that basically determines the, oh, I'm sorry, order by key selector. I get confused about what stuff's in my libraries and what stuff's in the built-in, because I rarely use the built-in libraries. I mean, the built-in stuff without mine. So on GitHub, if you go to GitHub Dekunz, there's this good stuff library, and it adds a whole bunch of new methods. Like, for example, if you want to do something 10 times, you can just do 10 dot times, and then give it the lambda that you want to run right there. Let's go ahead and get good stuff in here. I, of course, have a copy here. Come on, good stuff. You can download it, compile it in exactly the same ways as I showed you. Apparently I need to do that because I've already copied it. I copied the DLL out into a different project. So here's good stuff. We build it. Oh, my bad. I was in the middle of refactoring a bunch of stuff. All right, I will just grab it out of a different project. Grab a clean copy out of a different project. That copy is not committed or anything. I'll just grab this one out of Emberscape. as you can see in Emberscape, we have, you know, we have a few components. These are all different components of different things to make the game work. And with our processors, these are all our different processors to make things work. They're pretty discrete, you know, a processor just for doing fuel bars, or a flight text manager, or certain parts of the player UI, or projectiles, or each one of those little kind of like aspects has its own processor. Okay, good stuff. Let's grab that and let's move it to move it over here. We'll copy it over here. Okay, cool. Now we got good stuff. Once it recompiles, we'll force that project to be rebuilt so that the project has a reference to the DLL that we just brought in. You can see those references here under references. This is where, like, this is how your project knows about Unity Engine and Unity Editor and all those kinds of things. It knows about RobotArms because we dropped the DLL in. It also knows about good stuff because we dropped the DLL in. So now that we have that, let me remember tiles. Hold on. Okay. There's two parts to this. There's Unity specific stuff in here, and more general just link stuff in here. So we're not using any of the Unity specific stuff. Tiles, order by. Weird. That signature is throwing me off, but this is what it does. So if we ordered by, let's say, the tiles game objects transforms X value, if that's what we, positions X. If that's the value that we use to sort, then what we should get back when we're all done, so let's get all these tiles, and let's just assign them to the tiles so that we can see them. I mean, we could debug log, like loop over this and debug log. I'm just gonna map.tiles equals new, and this is gonna be a tiles.length by 1 array. Actually, sorry. For the short term, while we're figuring all this out, I'm going to make this just a regular tile array, because that will make our life a lot easier. So this is a regular tile array, which means we can just do tiles to array. Okay, there we go. Now there's our tiles sorted in our array. And we're just doing this just so we can see it here in the editor. So when we hit play, we should be able to go to the world map, and we should be able to see this tiles populated with all the tiles sorted just by their X for now, because that's what we said. We said order by X. So we hit play, and what do we find first? We find dirt 12. Which dirt 12 was that? That has an X of 2. Okay. And then we have dirt 11. That also has an X of 2. So the first thing I'm noticing is, of course, this is going to put the biggest thing first. So we would want the inverse of that. We'd want negative X. That way the smallest thing would be first, not the biggest thing. Okay. So we run this again. And all right. Well, that's interesting. Did this not save or something? Oh, this gets thrown away. Tiles order by produces a new collection, so nothing actually happens. So now we'll actually, well, that's funny, we weren't actually sorting them. It just worked out that those first two ended up in the array first. So now we should be sorting by negative X, and we should actually get wow, that's pretty annoying. 12 is always showing up first. All of them are in here. dirt 12, dirt 11, wall 1, wall. And wall 1 is there, and wall, oh, that's not wall, it's wall. So these are all the 4 largest X values. Maybe I had that backwards. All right, there we go. So wall 10, yeah, is a leftmost tile. Wall 8 should be another leftmost tile. Okay, so we're getting all the small tiles now, or all the 4 tiles that have the smallest X, and then if we go, say, to the 5th element, so 1, 2, 3, 4, if we go to the 5th element, 9 should be in this second column right here, and we see that it is. So what we need to do now is sort by not just the X, but the X and the Y, and we want the Y to count for a lot more than the X. So we want to make the Y be a large number. So we're just gonna multiply that by 10,000 to make sure that whatever the Y value is, that one Y comes after any X at a lower Y. So we should multiply a sufficiently large number. I mean, theoretically, your map tile could be at like 100,000 and then this would get messed up. That seems unlikely that you would have a grid that big. So we do something like this, and now we run this, and now we should have actual proper ordering. So our first tile should be 8. We should see 8, 9, wall 3, dirt 8. So wall 8, dirt 9, wall 3, dirt 8. And we see, what do we see? We see wall 10. So our Y's get smaller as they go down, but our X's get bigger as they go right. So our Y's are inverted. So we actually need to invert the Y's. Okay, so wall 8, yes. Dirt 9, yes. Wall 3, yes. And dirt 8, yes. So now we're going across in order. So 1, 2, 3, 4, 5, 6. This should be the far top right. Yep. And then if we go to the 7th, it should be the first of the second row. Okay, cool. So these are all now correctly in order. Cool. So here's our tiles ordered. In fact, we might just do this. Okay, so the tiles are game objects that are of a certain type, ordered by that ordering, and converted to an array. Okay, so that's our first kind of step, and we sorted find all the tiles and sorted them. We've done that. Now we need to determine how many tiles are in a given XY. Now the reason I converted it to an array is because with link you get back an IEnumerable, and you'll get errors about multiple enumeration of an IEnumerable if you try to seek through it. There's no guarantee that it's restartable. If you do a link operation on an array, you know under the hood it is restartable, but generally speaking, if you just convert it to an array first, like in the midpoint, then you're fine. Okay, last thing for today, I think. So we've got our tiles. They're sorted. Now we need to know how many are in a given Y. So we can just pick the first tile's Y. We'll do the same thing for the first tile's X to find the X's. So we could find tiles at index 0. So that's the first one's Y. And we want to find every, this is like our target Y. And we want to find all the tiles that have that Y. So every tile that has that Y is how many rows there are, and the number of tiles that have a certain X, and it's of course not this, it's It's the tiles, game, objects, transforms, positions. Why? It might be worthwhile, since this is going to be a pretty common occurrence for tiles to know their position, to have tiles at the beginning all go and set their XY to a certain, to record their value. That would work as long as tiles never move. So then we need to update it, of course. I don't think tiles are going to move. That seems, I think if we did anything, we would swap the types of those tiles, but we wouldn't actually move the tiles. So, although I mean that's something that could be dealt with later. So I think there's going to be a very simple processor, a tile processor. Okay, so we got a tile processor, and this tile processor, all it does is it also doesn't have a process. It has a initialize, and it's going to take this tile, and it is going to say the tile is going to have two new things. The tile is going to have a tile type and a public. We want this to be a vector of some sort, and you could use a vector too, but then they're floats, and we really have a vector as really we're using int values, so that's kind of icky. So this is the point at which I would go pull in one of my vector2i classes from previous projects that I've written. They're pretty simple to write if you want to write your own. Let's see, a project that would have a vector2i. Let's go find vector2i. Vector2i, used it in a few different projects. Come on. Basically, all you want to be able to do with a vector2i is you want to be able to create them with a nice little constructor, get their things like their magnitude and square magnitude, do things like distance operations, be able to add them, compare them, that kind of thing. So that's what this vector2i class does. And we'll just plop that over here. Did that not copy? Marvelous. Okay, copying that, pasting. Okay, there we go. So there's our vector2i class, and we'll want a vector2i called position. So our tile processor, and so the tile's position is a new vector2i, and the 2 points here are the entities transforms positions x as an int. So we can just cast this to an int. Should already be, we can use like a round, we could use mathf round to int. That's the safest in case it's a little bit lower, so it doesn't get truncated down. If it's 0.9999999 instead of 1, it doesn't go to 0, it goes to 1. Okay, so we pass those in, and there we go. So that sets up our okay, there's our vector2i. And we want to make sure that this processor runs very early. So this is a process time where we would put a very large value in here to make sure that the tile processor runs before any other processor. So the tile processor is going to run first. So when the world map processor runs, the tile processor will already have it'll already have its value set. So now we can just do t.position.x. We order by those two things, great. And now, okay, so the target y is whatever tile 0's y value is. So this has a y value of 1. So we want to find out how many things have a y value of 1. So we want to find a count. So that's pretty straightforward. In fact, we probably can rewrite this if we do tiles count, and then count takes a check. It'll count all the elements that match the predicate that you give it. Predicate is just a function that returns true or false. So if we do a count, we want all the tiles whose position y equals the target y. And this is so this is all the ones that match that y. This is the number of columns. And of course, instead of doing this, we could just put that in here. Could argue if that's readable. It maybe starts to get like there's a bar here, and I've at various times in my career had different opinion on that. If it's okay for code to just go flying out past here, you'll notice that here I kind of broke it down to multiple lines, and over here in the tile processor, over here I also wrapped this so that everything was indented and you knew what belonged to what. That this is all part of this equation, or this expression, I should say. That's mostly just preference. But I do think that keeping things short is generally a good idea. So if you need an intermediate variable to keep that short, then do the intermediate variable. This is nice and clean. Then there's no, intermediate variables are nice to keep things nice and compact, but if you don't need the intermediate variable, then it's one less thing to get confused about. Like, oh, what does this thing do? Oh, it's only used in this one place. If it's only used in one place, and you can inline it, probably better. So we've got the number of columns, number of rows. Okay, so cool. That was this stuff. After we get the counts, now we can create the tile array. All right, so why is this not uncommenting? Right, create the tile array. It's going to be the x, so that's the number of columns first, and then the number of rows. And of course, over here, we said that's not a multi-dimensional array, so we have to go and put that back. So now this should work. This is a new tile array, not a tile type array. And now we can finally insert the tiles into array. Okay, last bit here. So for each one of our tiles, we want to put that tile in the map.tiles at its correct column and row. And so to do that, we need to know what the this has an actual xy in the world. This has an x of -3 and a y of 1, but in our logical view of this, this is 0, 0 in terms of indexing. So we probably should have some sort of world to map conversion functions both ways, from world to map and map back to world. Those are pretty common when dealing with 2D arrays. Also, we're going to need to know from here, if you click on a tile in the world and you want to go find the corresponding tile in your array, you could go through all the work that we just did to figure out where does it start and all that, but you're not going to want to do that. You're going to want to have a you're going to want to know an offset for the world x offset and the world y offset, and these are basically the offset for where you find the difference between the position in the world and the position in the array. Now we do have a little bit of a problem in that So the array is going to grow down. It's going to grow, so the x is going to grow this way, and the y is going to grow this way. We probably should, in actual world coordinates, the y value grows up. And without like, flipping this around or doing something like that and looking at it backwards and losing our like 2D view and all that fun stuff, we probably should stick to that, which means our logical array, 0, 0 in our logical array should probably correspond to here, and then 1, 0 should correspond to here. So what we really need to know is we need to know this xy here. This is the offset. So if you have 3, 2 in world coordinates, and we record that you have a, of course I did this wrong. This should of course be a world offset, and this should be a vector 2i because that's an xy value. So if world offset has 3 or -3, -3, -2, we would subtract that from your current position. So -3, -2 minus -3, -2 is the same thing as plus 3, 2. That would end up at 0, 0, and therefore your tile right here would end up at 0, 0 in the multidimensional array. That's the idea. So we're going to need a couple of little helper functions here. So let's, these don't need to be public. I make all my helper functions static because, well, there's a philosophy behind programming that we're trying to aim after here with RobotArms and whatnot, which is a fairly functional style. And it means that if you can make a function or method operate purely on the parameters that are passed into it and then return a value back, like not just go mutating things, it is much easier to reason about. So in this case, world to map is a great candidate for this kind of thing. It is very easily purely functional as long as you pass in the offset. So we have a position and we have an offset. And you might say, oh, just don't make that static, and therefore, it can, it can read things that are part of the class. But in this situation, the processor actually carries no state with it, so it makes sense to make everything static because what variables from up here would you be accessing? Everything's on the is on the entity or the map or some other component. So generally speaking, you generally speaking, you have to pass the stuff in anyways when you're writing code like this, so it works out really nicely. I'm trying to figure out is this just yelling? Okay, so that's fine. It's just yelling because this isn't returning a vector 2i yet. So what we want to do is we want to take the position minus the offset, and that's what we want to return, I think. And then if it's what is going on here? Oh, we're outside the class. Whoops. Okay, that's a lot better. Okay, so that's the world to map. Map to world is really just the inverse. It's you take the, and of course this could get more complex, which is why we have a nice little helper function. It'll be the position plus the offset will take us from 0, 0 on the map, plus our offset of like -3, -2 will take us to -3, -2 in world coordinates. So what we want to do is we created our map tiles, and map tile, so for each element in tiles, we want to take its world position, convert that to a map position, get its enum value, and then, or sorry, not get its enum value, just assign that tile at that correct XY position. So we want to do something for each tiles. So we could do a for each, we could do this. There is a good stuff method that accomplishes this. So the equivalent of that is tiles each in good stuff. It's like this. So for each tile, And then, of course, if it's like a little one-liner, it becomes like very trivial. You can actually do it as a one-line lambda. So in this case, yeah, it really wants to put that there. Okay, so for each tile, we want to go into tiles. That is obnoxious. What is going on here? Tiles at the tiles. Okay. This is the map position. Is going to be the world to map on the tiles position, along with the maps world offset. So that's our tile position converted to a map position, and then we can take the map position, and of course that map position.x and map position.y is our coordinates that we want to insert the tile at. So do that. There we go. So now we've inserted all of our tiles into our array. That's what this one is. Hello, person who just joined. I don't know if I can actually, I don't know how to see viewers. Like, I don't know if you're the same person or someone new. Feel free to ask questions. We're basically about to wrap up here in just a second. If you're wanting to catch up, we've been using RobotArms to make the beginnings of a sort of a tile-based kind of turn-based roguelike kind of a thing. All right, what did I mess up here? Tiles. Oh, sorry. This is the maps tiles, because we're inserting into the maps multidimensional tile array a specific tile. All right, the moment of truth. If we run this, do we get our tiles in the right order? And the answer is no, we get a bunch of exceptions. So let's go see what happened here. Array index is out of range at line 32. So one of these has gone horribly wrong. This is where I'd probably just start figuring out what is being returned by these such that we might have gone wrong. And let's just get rid of this extra stuff we had here. Okay. Lots of link, yes. I don't know if you consider that a good thing or a bad thing. I love link. Link is going to make your life a lot easier in most cases. As I had mentioned earlier, that's pretty much all what good stuff is, that good stuff library. It's a bunch of extensions to link. If you have problems with link in performance, you can always convert it down to a for each loop, or something like that, or just a for loop. But I found that usually that is well more than a little increase of your code. That's often a huge increase of your code. So at least early on, you want to be very wary about that kind of thing. Oh, we never set our... did we set our world offset correct? Whoops. Did we set our world offset correctly? We wanted to set the world offset based on the... Yeah, it makes life a lot easier. Sorry, we wanted to set our offset based on this tile right here. This is the tile. So whatever its XY is should become the map offset, but we're not actually setting that anywhere, which is why we're getting index like -3, which is clearly not correct. So the world offset should be the first thing in the array. Well, hold on. We can test this real quick by printing out tiles at 0 position. Or, yeah. Okay, so we'll run this. We should get -3, -3, 1. That's correct, because we sorted such that we're going in this order right here. So this object right here. Oh, sorry, -3, 1. We're getting this. That's the wrong order. We sorted before because we were going from the top to the bottom, which is the way I thought we were wanting to go. That has proven not to be correct. So we'll reverse the sort order. And instead, now we should get 3, -2, which is here, 3, -2. Okay, perfect. This position now is our world position. So we want map.world offset to be that vector 2 right there. All right. Now we can turn these back on. And now we should not get array out of index exceptions anymore. Haha, except we are. But we're getting, let's see, we're at 0, 0, and then it says we're out of range. Why is 0, 0 out of range? We created, well, just to sanity check myself, let's print out columns and rows. Oops. 6 and 0. Well, the 6 is correct. That 0 is not correct. 1, 2, 3, 4. Yeah, we got 6 columns came first. Yep, 6 columns, 0 rows, huh? Well, that doesn't look right. So rows was the count. Well, that'll do it. Sorry, that should be X, and this also should be X. Yep, because we want to find our rows are all the values that have a certain X. Any given X. Yay, programming. Okay, we get 6 and 4, and hurrah, we are no longer exploding in the fireball. Okay, so let's go look and see if our array, multi-dimensional array that we built actually shows up. And now that I think about it, Unity does not display multi-dimensional arrays. It doesn't have an editor for it, which is a huge bummer, because the whole point of, well, not the whole point, but a large point of doing RobotArms type stuff is so that you can just go in the editor and pause it and see what's going wrong. So that's kind of a bummer. We could get around that, of course, by using a single dimensional array and then just recording a number of columns. That's the only thing you need to know. You don't need to know the number of rows, because you can take the overall and divide it by the number of columns. You get the number of rows. You can take the total length of the array, but you do need to know the number of columns. I guess technically you could get it from the number of rows, but it's way more convenient to have number of columns, because you end up using that one quite a lot when you're iterating. So, I guess we'll store it as a single dimensional array. That way we can at least see what's going on. Or we could write a custom editor for the map that takes the data from the multi-dimensional array and shows it. That would be... Well, it's pretty easy to get the current. Well, given an index, what we want is we want a vector 2 to index is what we want. So we want this to be a map to index, and so this takes a vector 2i and the position. Why do you do that? And the number of columns, and given those 2 bits of information, we can take the position times the number of columns plus, sorry, the position's x, sorry, position's y times the number of columns plus the position's x. No. So the way this works is, if you have a vector position, if you're, say, here, you take your y value, which is 1, times the number of columns, so there's 6 columns, so that's 6, plus your x, which is 3. Well, it'd be 2, technically, here, because this is 0 through 5, so 6 actually takes you here. So you're at, your y is 1, so that's times 6, so you're at 6, plus 2, 7, 8, and then that gets you right here to this index. Right. Thank you. I guess it's maybe easier to say the x plus the number. Yeah, I usually think of it as use up all the rows first, and then use your x to kind of fill in the last little bit. So that's your map to index, and then of course we need the other one. We need index to map. This should be index to map. I think that's a bad name actually. I think this should be map position, just to indicate that it's like an XY. So we have an index and number of columns, and now we get to go the other direction. So we get to take the x is going to be the remainder. So we're going to return a new vector 2I, and the x value is going to be the index divided modulo the columns, because we want the leftover of dividing the index as many times as we can use up columns. We want to use up all those columns, and whatever's left over, so if our index is 8 again, we want to take 8 divided by 6. We end up with 2 left over, and 0, 1, 2. Yep, that's the correct spot. If we were on this space instead, we would be at 8 plus another 6, so 14. We divide by 6. We modulo 6, which would again result in 2. So there, and then the y is the index divided by the columns. Okay, cool. We got those two little helpers. Bam. And let's see. So this is going to be the columns times the rows, because it's a single dimensional array now, not a multi-dimensional array. And now when we insert, we don't insert here, we insert at map position to index of the map position, which means we really could, this needs to be world to map position. That way they're consistent across. Okay, technically, yes, we could go cram this right inside here. Like I was saying before, that's largely preference. I like to keep things on the shorter end. So, what did I mess up here? Index map position returns a vector 2I, not an int. Thank you, compiler. All right, let's go figure out if this worked now. No overload for, oh, I need to pass it the number of columns. Right. Okay. So let's try running this again. We go to our world map, and what do we see? Well, that's definitely not right. So we get wall 8, followed by dirt 9, followed by wall 3. Okay, so it's going across. It's just going across in the wrong order. It's using the values with the highest y, not the smallest y. And it only inserted, oh, map position index is somehow wrong. It inserted the same, inserted the 6 like over and over. Sorry, what were you saying? I didn't see you set the number of columns. That would be 0, and that's why it would keep overriding the same first 6 elements over and over. Okay, so number of columns clearly needs to be initialized, probably right here. It makes sense that we do those two in the same place. So we determine the number of maps and rows and columns. We figure out the world offset, the number of columns, set up the tiles, insert them all. All right, yay. Wall 10 is at the bottom, perfect. Wall 9 is the next one over, fantastic. Wall 6, and so on. So the last element should be in the upper right-hand corner. Looks good. So what all this was about was simply setting up the data on the world map. you know, the number of tiles, the number of columns, that kind of thing. The next step would be, which we're not going to have time for tonight because we've already been going for like an hour and 45 minutes. But if people are enjoying this, we can certainly do this on another day. The next thing is to use this map data, have this map data in some location where the player movement processor can get to it. So now when you go to actually move, you do a check first. You know, check if all tiles leading up to target position are clear, and move only the number of tiles that are clear up to that. So it would try, you know, try the first tile, then try the next tile, and just keep moving. And so the player movement processor needs to know about the world state. It needs to like be able to get to this world map and look at these tiles so it can look at the player's position, which, now that I think about it, the player has a, whoops, that's the old player. That's not the player we're using. The player has like a health and a move speed. It doesn't have a XY coordinate kind of a position, and it actually makes sense that it probably should. I mean, we can always get that off of like the world position, but it's just so convenient when you're dealing with like vector 2i's to just be able to snag that. So we could set up the position, and then in the player, I'm going to put this in the player movement processor. There's a couple different places where we could put this. Actually, that's on the player stats. So I would probably, in this case, actually create a player stats processor. It's going to do other things eventually. But for now, the player stats processor. And get rid of this, and get rid of this. Okay, the player stats processor will just initialize in the same way that the tile processor had to go like find the position of the tile and set that up. And now is a good chance to discuss one other thing that comes up pretty often. Okay, so we're just going to end up doing almost this exact same thing right here. Player stats. What are my player stats processor? Okay. This is initialize. It's the process, and it's not the, it's the stats position. Okay, so we'll just grab that there. I thought this was going to bring up another issue, which is being able to convert these. Let's say that we had another processor that needed to be able to do these kinds of things. That seems really likely very soon that we're going to have another processor that needs to be able to do these kinds of conversions. Because everything is written in this manner where no state is stored in your processor, and every time you call one of these little helper utilities, they are pure functions in the mathematical sense, like everything they do operates on their parameters, and you know, they just return another value. It's incredibly trivial for us to take these out and just plop them in the utility. So we have some sort of like map utils. We grab these out and put them in there, change our usage of it to be map utils dot in these places, and now we can share it across multiple processors. So code, you know, can stay these private static methods as, you know, nice helper utility methods for your main, your initialize or your process. And then as you build them up, as soon as you discover another place where you need it, it's very simple to just pull those out and put it somewhere else. And that's what we'd start to need as soon as we went down the path of needing to check things, right? We would need to go from our position as a player and then go look up the grid, the index of the position, say, above us, and then check the tile to see, is it solid, is it occupied, things like that. One thing we didn't really put in here in the tile was like a, you know, some concept of a actor that could be a player or an enemy, some sort of generic actor thing. And that actor, again, that's not like a base class, that's not like a, it's nothing like that. It would be just another component that we would throw on both the player and the enemies. So we could have a player, and we could have a, you know, whatever, a ghost, and our ghost could have, let's go grab one of these other sprites that we have under sprites, and we could have a ghost here, and is that actually the pivot? Wow, that is really terribly offset. Okay, well, I wonder if the player's that way too. Oh goodness. Well, that would have gone badly if we'd tried to, tried to actually run that. Okay, so you have your ghost, and you would just put, so we could put a component on here like, this obviously wouldn't have player stats because it's not a player. Probably what would happen is this would become actor stats, anything that would be shared between them. And then if we need to have extra player things like number of charges for an ability, health regen, if health regen is a concept that's unique to players, things like that, that would then go on to player stats. So a player wouldn't have like a player stats that's a subclass of an actor stats. It would just have an actor stats component and a player stats component. And the nice thing about that is then the this is currently player stats, but this probably realistically should be renamed like actor stats to be more general. That would just continue to work, and now it would also work for enemies. All the enemy stuff, like the player stats processor we just created. In fact, let's just do that. This is now actor stats processor. Yep, and this class is now actor stats. Okay. So all that's good. Of course, we need to rename this class, which will break it in Unity. Okay, so we got actor stats. And now we come back over here. I mean, these are the kinds of things you figure out as you're going along, right? You just kind of one little where do you, oh, it just wasn't saved. Okay. Okay, so now we can actually assign this thing. This is an actor stats here. All right. And now we can give the ghost also an actor stats. And now when we hit, you know what I forgot? I forgot off our vector2i, I forgot serializable. So we can see the darn thing over here. We should be able to see a position right here. There we go. Okay, there's our position, our XY. So now when we hit play, the ghost should get its XY position, which it actually is XY, kind of worked out that way, and this should be -2, -1, and that got set as well. So we didn't have to like account for or do anything new for the enemies or objects, or I mean actor, like in Emberscape as an example, everything's an actor. Like projectiles are actors, traps are actors, enemies are actors, players are actors, like everything's an actor. And then we have a whole bunch of stuff that just is common to things that exist in the world that we call actors, and as a result, we don't have to do a whole bunch of like, there's not a lot of weird subclassing, and the subclassing gets weird because it's like, well, an enemy and a player, those are related, but a trap isn't an enemy, and a player's not a trap, and like you get into all kinds of weird situations with any sort of inheritance hierarchy. So, but just by having components, like just because this has an actor stats component doesn't mean it can't also have a player stats component. And the enemy can have like an enemy stats component. And then the processors that are specific to say player stats, like if you have an actual player stats component that only wants say player stats and actor stats, none of the enemies will get passed into it. Only the players will get handed into it. Because a processor only receives a game object, an entity, that has all of the components that it's asked for. That's one of the, so you get automatic like filtering in that regard. So I think that's where we're gonna end up for today. I don't actually know a good way for people to, if you like this or you want to see more, you should just like shout out to me on Twitter, just send me a tweet or something, or you can probably send me a message directly through here, and I'll look into doing another one of these at some point and going further either with this project. I'd like to develop this into an actual real game at some point. It's kind of like my side project. I'd also like to stream full Emberscape. That's a little harder because it's a big complex project and we're kind of right in the middle of it. So I could maybe grab parts of that and show what's going on there. That won't be as instruction-y, like I won't be able to talk through as much of what I'm doing, but it would let you see inside a large complex game. We're doing networking, we're doing all kinds of things like that. So thanks you everyone for watching. I think this worked pretty well despite me not knowing how to use Twitch very well. And I will see you all next time. I will announce it on on my Twitter feed. So if you follow me on Twitter, I'll definitely announce when I'm getting ready to stream, and I'll try to do it sometime in advance, like at least a day. Oh, thank you. Yeah, just send me a tweet. You can subscribe there, and definitely let me know what you'd like to see. Here, I'll stop the stream, and we can just chat about that. Okay, thanks everyone.